So very good. Let me see if I can start here. So yeah, this integration, delivery, and deployment. It's the chapter. Um, One of the interesting things, continuous X, is that I was not aware about this website. Just Humble, like maybe everybody knows who it is, but I just learned from the book that this website exists. I don't know if I can open it. Um, because I always, at least myself, I get confused between continuous deployment and continuous delivery. And then sometimes you talk to other people and they tell you like continuous release. And then sometimes you hear the definitions different from different people. So I don't know. I think, is this serve as a canonical reference? I think I wasn't not aware, like Andy or Hilary or Max.
Yeah, so I think the reason why I put it in there is because we didn't want to kind of re-explain all the details about continuous delivery, but we wanted to give an overview in the book, but then reference more in-depth content. And obviously, Jess Humble, his website here serves as a great introduction, or like a great deep dive into the topic. But in our book, we also covered, or at least in this chapter, I tried to cover different aspects from CI, CD. I think you said, I'm sure there's different definitions, but for me, you should separate between delivery and release. Delivery means you're delivering your artifacts. Releasing means you're making those available to your end users, whether it's through your blue-green deployments, through Canary, through feature flags, but basically have a separation between delivery and release. That's what we kind of talk about here.
Can you explain a little bit more about the difference? Like release is like rolling out the new version with the different strategies, and delivery is what?
No, for me it's the other way around, right? I deploy a new container version, but it might not yet be released to the public, or it might just be released to a certain set of users. So this is the way I see it, and we've put it in here. So continuous deployment means you can continuously deploy updates to a certain environment, but then you can control and separate what you actually release to your end users, what is really available. And I think we highlight the blue-green deployments, Canary, feature flags.
Here, people can see it. Hilary, you have your hands up. Go ahead.
Yeah, so I think the easiest way to think about this is the continuous deployment. Like Andy said, that's more about reaching an environment automatically, but not actually users. So that might be staging, or your could be like your load test environment, stress test environment, something like that. But it's not like, because if your system ends at your CI/CD system ends at deployment, then that means you're manually releasing or delivering to customers. That's like probably a manual piece, right? A manual step. It's not automated. When you have continuous delivery or continuous release, those are kind of synonymous. You're getting it all the way automatically into the hands of end users. And whatever that process looks like in like terms of implementation details could be like highly variable. It could be everything at once. It could be Canary, blue-green, phased rollouts, whatever it is. The method of doing that is not specified. It's just what the end state is. And the end state is it's automatically in the hands of your users. So a continuous deployment may be a step along your continuous delivery pipeline, right? That delivery is all inclusive, whereas deployment absolutely ends at it being an environment, or the maybe the creation of the manifest, but it doesn't actually put it anywhere in front of a user via automation. That's usually a human step still at that point.
Yeah, and it mentions here the delivery to the hands of users, right? When getting it to the hands of users, and then down here is the deployments, different type of deployments, right? How you want to do that deployment, right? The blue-green, the Canary, but I like Hilary's explanation. Like you may be deploying to an environment that users are not using the software, right? You're deploying it for performance testing or just UAT testing, like manual testing. But eventually will be deliver, right, or release. still not confused about that. But
I think this is one of those things where the industry is evolving, because 2 Ds for CD is confusing. So people are starting to say, okay, let's call it release. And then some people are still like, let's call it delivery, because that's the older version of the term.
okay.
So I think we're having an industry split right now, where there's the language is evolving and there's yet to be a complete agreement. I have a really good example of continuous deployment versus continuous delivery, which is in the pre-Kubernetes days. I worked at a company where we automatically deployed our software to all of the servers. And after testing was finished in the staging server, we actually swapped DNS to point to the staging server. And then the previous production server went into what we called holding, which was if we needed to roll back, we just pointed the DNS back at the old set of servers. And so that's like, the continuous deployment work, like automatically put all of the code changes onto the server trio. It was like a three servers with a load balancer, et cetera, right? It automatically did that, but the actual putting it into the hands of the user was our sysadmin going and changing the DNS record. And if you guys know Christian Hernandez, that's who that was.
Okay,
cool.
I
worked together. Yeah.
Cool. Yeah, I know Christiana. We're doing some live streams soon. The other book, maybe to reference, is this one of the first books that I read. When was this published? Cannot remember. It was so many years ago. Let me see if it's here. 2018. Yeah, maybe this version. But Accelerate is a book, and I think it covers also. This was the first time I saw the release process and like continuous release and continuous deployment, and I think it has a definition of those in there. So that's a good book, at least when I read it back then. I think it was 2019 or something. So the next one is continuous. This one is new for me, like continuous X for infrastructure. And it mentions CDK, mentions Ansible, Puppet. What's the take here with continuous infrastructure?
Well, I think it says is in the first sentence, continuous, whatever you call it, is not just relevant for application code or configuration changes for the application, but you can also apply the same thing for infrastructure changes, right? If you need to roll out new servers, new infrastructure as part of an application deployment, then you should also, like you do with your code and your deployment definitions, use Git to describe, or use whatever tool to describe infrastructure, use Git to store it, and then use your automation tools to then apply it as part of the rollout. So that's kind of the idea, right? It's not just that before you can roll out an application that has new requirements to certain infrastructure components, that you first need to do this manually, but that you basically apply the same principles. Everything that we've done in code, CI, so putting things together, doing some testing. You can also test your infrastructure definitions, right? You can test your Terraform, your CloudFormation. So everything we've done over the years in software engineering to increase the quality of our changes, we should also apply this to any infrastructure changes we do. That's kind of the idea.
Yeah. So these are things that don't necessarily are containers or configuration inside Kubernetes, but the infrastructure or maybe dependencies or where Kubernetes gets deployed, and it should have the same software engineering lifecycle of like versioning things, right? And versioning modules. That's something that I've seen, at least in enterprises that good. For example, a big Terraform, like teams would like create modules and release them with the version, and sometimes they use a registry and sometimes they just use a GitHub and a tag. But they are like very strict that have automation, like if some PR change to the Terraform module, then that gets bump, right? The module gets bumped, and then everyone that is using that module start like picking up the changes. It could be a feature, it could be a bug, but treat it as a software lifecycle. And then you talk a little bit about Terraform, Crossplane here.
Yeah, exactly. I think this is the first or second time we mention Crossplane in the book, because, as it says, infrastructure as code is not limited to the core platform services, but you can I think we have an example here. If you remember, I think it was in chapter 2 or 3, we explained one of the use cases that we want to implement in platform engineering. So for instance, an automated self-service way to get a certain application version load tested. And in this example here, right, we are providing a cross-plane composite definition for a performance test cluster, where we say we want to have a medium-sized cluster, we want to have a certain application deployed in a certain version, and then we want to run some spike load, and we want to have observability turned on, and if something happens, if something is done and ready, then we want to be notified on Slack, and the whole environment should be available for 12 hours. So here we kind of also show how infrastructure as code can really span a complete self-service use case.
Interesting. And you have a lease time of 12 hours. It says also to be shut down.
Yeah, lease time, it's basically, right, if a lot of, at least challenges that I've seen, is when people create a new test environment and then they turn it on, they deploy, they run some tests, and then they leave it running, and nobody thinks about cleaning up. And so enforcing things like a lease time, which automatically shuts the system down after a certain time, right? It's like if you are renting an apartment, if you don't pay it, I mean, it's like you rent it for a certain time, and that's the same thing. You're renting that particular environment for a certain time, and then automation makes sure to shut it down.
Yeah. So let's talk a little bit about this use case. And I know a little bit of Crossplane. I've done a little bit of Crossplane. So if this object is going to create a new cluster, could also create a lot of infrastructure, right? Create the Kubernetes cluster in a managed provider. It creates maybe a database. It creates like this is behind this is it's a composition, a Crossplane composition of creating a bunch of objects. And this 12-hour, have you implemented this scenario? Like what do you do with this number of 12H in this case? Like, because this is desired state, right? If you follow, like this is a desired state that I want a cluster always to be there, right? Reconcile cluster to be there, the VPC to be there, everything to be there. But then there's one field that says like to not be there after 12 hours. I'm a little bit confused.
Yeah, that's the again, it comes back to the use case we described in the very beginning. The whole financial one, Acme, fictitious company that we create. One of the use cases that the developers wanted is an easier way to automatically through a self-service run a load test, but also clean up afterwards.
Yep.
And so there was kind of like one way to implement it to extend your if you're using Crossplane, you don't have to use it, but we brought an example here, and then obviously you would need some automation that would then essentially kill that object and then clean up afterwards. But it was one of the problems raised that right, if you provide a lot of self-service and you make it very easy for people to create new resources, then you also want to make sure that it's also properly cleaned up, and it's kind of like putting this into enforced cleanup.
Yeah, the thing that I'm asking, like if I'm going to sit down and implement this Crossplane API, I would not have, at least myself, I would not have that field in there, because the act of doing a kubectl apply on this, it will create everything, and the act to delete is basically a kubectl delete. So you need like something else that runs at 12-hour time.
Maybe you need an operator. Maybe you need an operator that then takes care and watches it and then deletes it for you. Exactly. Yeah.
But in this case, Crossplane is actually an operator, right? It's an operator creating resources, and people use it because they don't know how to write operators. Most of the end users that I work with, they want to use Crossplane because they don't know how to do kube builder, they don't know how to do Go, they don't know how to do operator. But I think it could be done in terms of like a CI/CD pipeline or something abstracted on the top, right? That watches when it's time to delete and it will clean it up.
Yeah, but the point that we wanted to make here is, right, this is kind of the definition. You have a certain use case and you want to make it easy for people and to use it and define it. And so
defaults, right? Like if you don't put it, like it will default to like we don't the default is like 12 hours, but if you want it more, like change that number to be larger.
Yeah. This was also inspired on what we do internally in our company, right? When I create a new resources on let's say AWS, like EC2 instances, then I get a default lease time if I don't specify something else, and I get a notification 12 hours before my lease runs out, and I have an option to expand it or just live with it and then have it automatically shut down.
Perfect.
Yeah.
And then this is the aspect of monitoring and observing the tools, the Argo CD tools. Is that, oh, this is specific to Argo CD?
Yeah, it's not just, I mean, this was an example, a screenshot from an Argo CD dashboard, but I think the point that we make is whatever tools you put into your CI/CD tool chain, right? Whatever Git you use, whatever CI you use, whatever CD you use, you want to make sure that these systems work as expected. Because if they don't work as expected, then your platform will not deliver on the promise that it's available when people need it. And so the point here is use observability on every component of your platform. So if your platform is a product, an internal product that you want people to use because it really solves problems, it needs to be available, it needs to be resilient, it needs to be fast, and therefore you need to treat it as any other product, and therefore you need to observe the product and every component that it consists.
Yeah, I think that's the theme from the beginning of the book, right? That this automation, these pipelines, this running software, right? At the end of the day, this is running software. You can say that it's not your software, but hey, you pick the open source project containers to run them. It's running software that you're responsible. And most of these tools have telemetry that are emitting events, and also your SLAs, which goes back to the platform as a product. And then all this telemetry, I think we discussed this previously, right? If you start collecting, I think it's in this chapter, you have a little table of an event being treated for different. I think I like that table that was in this chapter later, but it's like events. These things are emitting events, and then there's actions that are like taking like different actions, right? But it's the collection of the events needs to happen and centralized. So the next one is GitOps. The aspect of GitOps and showing kind of like the archetype. I don't know what to call this. Like you see that like the starting point for a lot of folks, right? When they start with GitOps. Can someone go through this diagram of explaining?
Yeah, I think the diagram is just, if everything, if we follow the practice of everything we do and everything we want the desired state to be, if that has to be defined in Git, then everything starts with a commit in Git, whether it's your source code, whether it's your deployment configuration, your infrastructure definition. But in this case, I think it shows, and I think that's that the line on the right side has been cut off, so it should go from the top right, then further down. So the point is, at the top line, an engineer is committing code. Then you have your build that builds the container image, pushes it to a container registry, and this can then open up another pull request in the Git repository that contains your manifest, your deployment definition. And then you have your cluster where you have like a tool. It says your GitOps tool like Argo or Flux that is basically making sure that whatever you have in your Git that defines your manifest and jars, so your desired state for deployment, that the cluster is up to date, that it's in sync, so that the actual state matches the desired state.
Yeah, and this is pretty like when you have like two people and you have one cluster and one image. One of the things that I like, there's a project out there called Cargo that is handling promotions, because a lot of environments they don't look this simple, right? So this is one cluster for one app, but enterprises that are building platforms, they don't have one cluster and one app, right? They have this cluster that you have to deploy, like I was saying, and then do testing and UAT, and then only then, if it works, then it gets deployed to the next cluster, and then you do more testing, different type of testing, and then you roll it out to the other clusters that are in production, because maybe the app needs to be deployed into the same version into different clusters. So the orchestration of that multiple clusters multiplied by multiple apps, the doing all that testing, and then when you push that image, handling the events, right, of like that image or watching that image that needs to go through this promotion cycle. So this is the start. They just highlight that this is the starting point for people getting started, but at platform level, if you don't have automation for that, like Cargo, or it could be other like your own Jenkins pipeline, right? It gets complex very fast, because a lot of people at least my experience, at least a lot of end users that I work with, they don't have kind of like the example that you see everywhere of having one cluster that has multiple tenants, like namespaces, like the dev namespace and the staging the namespace. At least I see everyone having just a cluster for dev and a different cluster for staging and a different cluster for production. They don't mix the environments. Like even those clusters are even in cloud. There are different AWS cloud accounts or project IDs. Like I don't know if you have any thoughts around that.
Yeah, I think later in the book we have a couple of examples. I think it's in, I don't know what it is on the virtual book, but I'm on page 177. I think that exact example that you just explained is also, it's figure 5.6. If I kind of get it right, I need to scroll down a little bit further.
Okay.
But
Yeah.
there's like I think it's kind of goes into that direction where we explain. And then you're right? Cargo. I think at the time when we wrote the book, Cargo was already there, but we also had. I come back also to a project called Captain that we created years ago, and Captain in the version 1 also did some of that promotion across stages. We then defocused or deprioritized on that feature because we saw, tools like Cargo coming up that also solved this in a much more elegant way.
Oh, really?
Yeah.
Interesting. Yeah, I'm not familiar with Captain, but I have come up in some of the canoe discussions. So I like this chapter that I cover a lot of patterns, right? So it also covers the pattern of like the mono repo versus a lot of repos, and you mentioned like if you have a lot of repos, like it's complex to manage a lot of repos if you or not. It depends on the automation. Depends, like it reflects maybe the organization, right?
Yeah, there's always pros and cons to everything, and I think right underneath that image, we also try to describe both the pros and the cons for both options. Yeah.
Yeah, at least I can talk about I'm more familiar with Argo CD than Flux, but in Argo CD, mono repos affect the performance because you're looking for changes. So you have to put annotations on the apps to saying this app is located in this folder. So when it happens, using webhooks and not pool. But one thing that I think Dan in the last scalability meeting, he was looking into doing sparse checkouts, I think is the terminology in Git, where we don't do a full Git clone of the repo. We just do a sparse based on the pattern that you put, and that's a feature that will come in Argo CD. So that trade-off of people are always choosing the multi repo to avoid the penalty of the performance. Mono repo would just work as fast, just a data point. But there's other pros and cons of organizations. Yeah, there's a lot of blog posts and discussions around like mono repo versus not, and folks. GitHub also, it's not about GitOps. It's just about like working with Git. Like there's owners files. Before in the past there was no owners files, and then those type of things. And you also talk about platform team and the development team split.
Yeah, I think it also references one of the blog posts from Red Hat. I think that Hillary back then gave to me. I found it. I don't remember, but because that's we said it in the beginning, we could have probably written a book that is like 5 times the size if you would have dived deep into every topic. So that's why we provided a lot of references to more detailed content on certain topics, because why reinvent the wheel or rewrite everything that has already been written? So with this, we wanted to really give a good overview of what are the different principles, the different patterns. And if you want to learn more, then dive deeper into existing material.
Yeah, this one was interesting. Not all registries support this, right? Be able to call a webhook when you push an image, but that is an integration feature that is very useful when you like want to be notified when a new image shows up and what so I'm working with the ECR team on this, and I think it may come in the future. But other registries, so I think Harbor has it, right?
Yeah, exactly.
But yeah, not everyone who uses Harbor in everywhere. It's like Yeah, but it should be, maybe that it should be a standard, right? Is it an OCI like registry standard, or like how that webhook should look like? What are the data that it contains, or not? I cannot
Well, I think
remember.
that the webhooks, like with most webhooks that I know, right, it contains all the relevant information about state changes. Like, hey, there's a new image being uploaded, or and then with all the relevant metadata that you can uniquely identify it. And then the idea with the webhook is, what you do with this data. You can, I think we explained it later on. You can use this to then trigger a pull request into the next stage. You can use it for observability purposes. You can use it for triggering scans. You can use it for notifying people that a new image is available. There's different ways of what you do with that webhook information.
In Argo CD, there's a project in the labs that's called Image Updater that it just pulls, right? It pulls for new images, certain tags, and then it would know that there's a new image available, and then go back to update your YAMLs with that YAML. And then this also was interesting. This is something that I go back and forth, different users, and the pros and cons on hub and spoke versus many to many. Like, any thoughts on this?
Again, it's just we wanted to provide different. We wanted to provide an overview of different models, how you can run this. You can have, as it says here, a model on the left, the hub and spoke, where you have an operator that fetches, that basically makes sure, do we need to update anything? And then it can push to multiple different servers. So to your performance problem that you mentioned earlier, this is one, let's say, Argo or Flux constantly pulling your Git repositories. On the right side, you have on every target server, many to many, your GitOps operator that all need to constantly fetch. So there's always, I guess the pros and cons is something that you need to figure out how it works best for you. But we wanted to highlight that these models exist because we assume that people that read the book, they might not be familiar with everything that is with all the different architectural models. And so we wanted to provide a quick overview. And then I think, again, we provide links to additional deep dive material.
Any trade-offs that you want to mention on these two?
Well, the trade-offs, again, I think to point that you will definitely have more traffic if you have many that need to constantly fetch your Git repositories on the right side. On the other side, you need to have the main on the left, the hub and spoke model. You have more communication between your hub to the individual spoke cluster. So it really depends a little bit on your architecture and
Luke mentions at the bottom, it depends.
Yeah.
Some of the it's not trade-off. It's like some end users have like blockers that they cannot not implement it, and one of them is like the hub and spoke. Some of these clusters, like if you put the GitOps controller in the hub cluster, network connectivity is either impossible or costly, right? Over like certain boundaries of VPCs and direct connect and private VPC. So people cannot just plainly cannot have that model, right? So it's also like what things you're able to do or not to do. And then the other thing is, if you're going to do with the Argo CD on every cluster, or Argo CD or Flux, right? Your GitOps controller on every cluster, that installation should be done with GitOps. A lot of people miss that point. And then they complain that I have 15,000 clusters with each one with Argo CD. Why so difficult? Well, because you forgot that you can use Argo CD to manage those Argo CDs and actually deploy them the first time. That's a pattern that I have in a workshop that I have, because that same reason came up a lot with end users. And also, just to mention, there's something, because I'm working on the Argo CD project. There's something that we're working in Argo CD performance-wise, that the hub and spoke right now, since it needs to watch all these clusters and apply all these clusters, it becomes heavy. So there's a project called the agent model, which is basically what Ubiquitous does, that it sends a portion, the app controller, down to the clusters, but you still have the visibility on the top, and then that overload of a lot of work just gets spread between the clusters. So it's a kind of hybrid thing. So if you are interested, you can check it out. There's 2 talks from ArgoCon that happened in KubeCon. What else? I think I like that you pointed out this, because it's something that comes up in real projects, and platform engineers, when they start adopting GitOps in their platform, those are the first things that the architects, right? That's the first things that they need to decide on how they're going to structure either the GitOps, the pipelines, and the clusters. Let me see what was interesting here. I think this is the one that you mentioned.
Yeah.
On the
Exactly.
Yeah. So nice diagram. How do you do this very easily in production?
Well,
Or how those platform things need to starting to start working on this?
Well, maybe let me just explain. I think this is what you meant earlier, right? So the idea is that you have your internal dev teams, bottom left, that are building new containers or building new artifacts and images. I also brought in here third-party vendors, because you not only run your own software, but you also run third-party software. They can also use the same artifact registries to push to you, which means once you get then the notifications from a registry that supports webhooks, for instance, you can then make sure that everything that gets uploaded has properly been tested, scanned. You can then tag it correctly and then say, hey, this is there's a new version of our CI/CD testing tool that has just been pushed, and now let's deploy it into the tooling server, right? I think the individual servers on the bottom right, these are tooling, dev, and then I have QA, US East, EU West, and then different prod servers in Google, AWS, and Azure. So the point here is that you can then deploy certain things in lower level environments or tooling environments, and then you can, once the artifacts are properly tested and scanned, and then through tags, they will then be promoted to the individual regions. And this is typically where you see also replication of artifacts into the regional registries, so that then these individual target servers can just pull the images directly from where they're located.
Yeah. This picture like looks more closer to reality, right? Like how things actually are when from the point of view of the organization trying to implement this, right? Versus from the point of view of a single vendor. And then the picture doesn't have all the things, but I like that you have the scan, test, and tag, something that is in practice. I don't see that often, but I always question in terms of that security of like, one example is like you're relying that the registries that are public or the Helm charts where they're located are available 100%, the SLAs, right? Or that they not tamper. A lot of organizations have to implement CI/CD pipelines that you have here, of having those Helm charts and those images, even if from third party or open source, always downloaded, scan, repackage, or maybe like wrapper around a Helm chart. Adobe does this, and then push to one or many registries. Like that's and then do the replication across all of them. So that piece in production, when platform teams are working, that's something that it takes time to implement, but other organizations are not even aware. So I like that you have the
I selected this after conversations with our internal team, so we do it in my organization, right? And this kind of reflects on how we are doing it.
That's how you do it inside the organization. You pull everything. You don't rely on anything outside.
Also the replications.
And the other thing, I don't know if it's scan or something. When I used to work in my other role, that I was in a service and in a service, and I own a service, I had to do legal reviews for every version of every open source software that I use in the cloud provider that I was working before, and that took time. Was not as easy as like, oh, there's a new cert manager version. Okay, good. Like, let's do the legal scan, pedigree, and hopefully the delta is small that you continue. But the first one, right? Any open source software, you have to do the legal scanning. Not all organizations have that requirement, but some do. That was like, I always include like that in CI/CD pipelines in terms of delay. In terms of this aspect of building and pushing artifacts to registry, I don't remember.
This is just some basics. This is really just, as I said, I think we repeating myself now, but in the book we cannot go very deep into everything, but we wanted to provide at least the basic foundation and then additional links to other material. And so this is just some very basic stuff on
how but I think what we want to do in this book club, right, is to talk about things that are not in the book, of like examples that go beyond what is in the book. So can you talk about an example of like, do you do a Docker push to the 5 registry, or do you use a tool like Scopio and Crane to copy the layers as it is? If you build again, you don't get the same result, right? So do you have experience with that area about like reproducibility of the images, and like taking the image as it is, and then copy it do a replication? I think Scopio and Crane are the only 2 that I know that can do that.
Yeah, that's a good question. I mean, we do. I mean, our images get built through our CI, which means, right, in our case, this is we have both Jenkins and also GitHub Actions that are building and then pushing it to our registry. For the full details on what else we do there, to be honest, I don't have more details yet.
Okay, but yeah, a practice that I see is in pipelines is you build the image, you do the SBOM, you sign, you push to one registry, and then you use a copy tool, like it could be Scopio or Crane, to replicate it. Or if you are using a service from a vendor that offers you of saying, hey, whenever this image shows up here, go ahead and replicate it in different regions around the world, right? And I don't have to do anything in CI/CD pipelines or Jenkins or tools like that. A lot of organizations actually opt for that, and the reason is because you want that image to be as close as possible to that cluster, and then that cluster have only access to those images, have permissions and those type of things. Yeah, and you have vulnerability scanning here. Is that something that what do you think? That's something that needs or different ways of doing the scanning, right? You can do it at the CI/CD pipeline can do the scanning, but also like the registry can do the scanning. There's some registries, I think, remember, is it Claire from with integration with Quay? I think that was from Red Hat. I think it was open source at one point. I don't know what hardware has for scanning, but registers became more feature rich with the ability of continuously scanning those images that are sitting in the registry. So people stop doing the scanning once when they build. Do you have any thoughts on that?
I know that security is probably more the topic from Hillary. Maybe one quick thought. If you do it at the registry level, then you don't need to replicate it maybe in multiple different CI systems, because large organizations like we, as I mentioned, we have different ways on how we build things historically. And if you do it then on the registry level, you have a central place where all the artifacts need to go through anyway. So that might be a more efficient thing. But Hillary, I think she raised her hand.
Yeah, and you're right on that, Andy. But the other part is you still have to know where these things are running, right? So you can streamline your security processes if you're careful. But ultimately, you still need to be doing some level of scanning at every layer, because you need to make sure, you need to not know just what you might be running and where it's vulnerable, but like where it is actually running. And unfortunately, even if you have everything in GitOps or whatever, there still could be somebody's running something, in a dev environment maybe, but still like that is not necessarily controlled via GitOps. So there's a lot of different like areas and aspects to the discipline around that. So that's just, you know, one example, but it is really efficient to know what you need to update by having it at the registry, right? Because that can streamline your patching process as a whole to a very significant degree.
Do you have examples of like either vendor or open source tools that will help you quickly identify when there's like this image has a problem and quickly get a table of like all these clusters, my 15 clusters, all the places that this image is located?
This is where observability tools come in.
Yeah, no? Observability tools come in here. Exactly. So there is something for cluster inventory. Let's think about this again when we actually get to chapter 7. And that way I'll have an answer for you on that. I have personally written tools to do this. But there is also there are scanning tools. I mean, I'm just drawing a blank on them.